Title of the first section today is Simplify Square Roots. In this section, we'll simplify square roots or radicals. First equation is square root of 125. Simplifying a square root, there is no single number times itself that equals 125. So to simplify the square root, we can do a factor tree. With a factor tree, we'll pick two numbers that multiply to get 125. Two numbers that multiply to get 125 is 5 times 25. Continuing the factor tree, 5 cannot be factored anymore, but 25 we can factor. 25 would be 5 times 5. After the factor tree is fully complete and cannot be simplified anymore, a square root, we're looking for two numbers or pairs of numbers. We can circle a pair of numbers like a pair of 5s, and any numbers you circle, your first answer would be 5. Any numbers that we did not circle as extra 5 will stay inside the square root. So our final answer would be 5 square root 5 or 5 radical 5. The 125 and 25 we don't use because we factored them. We only use the numbers at the bottom of the factor tree. And second question, last question for the section. We have the square root of a fraction, 350 divided by 81. Simplifying a square root with a fraction, we can take the square root of the top number or numerator and also the square root of the denominator. The first number, 350, we can take the square root of, again by doing a factor tree. You can pick any two numbers that multiply to get 350. If the number ends in a 0, we can use 10, 35 times 10. Factoring further, 35, two numbers that multiply, we can do 5 times 7. And two other numbers that multiply to get 10, we can do 5 times 2. Again, once you factor or do the factor tree, the square roots means we're looking for pairs or two numbers that multiply. We have one pair of 5s, which we can circle. If you circle a single pair of 5s, again, the number outside the square root would be 5. We have two numbers that we factored, or the prime factors that we did not circle, 7 and 2. Those will go inside the square root and we'll multiply them 7 times 2. For the denominator, square root of 81 would just be 9. So our answer would be 5 radical or square root of 14 and divided by 9. Title of the next section is Square Roots with negative numbers. In this section, we'll take square roots or radicals, but the number will be negative. First question is the square root of negative 1. There is no number times itself that equals negative 1. So a new definition that we'll use, or a new variable, letter I, will be an imaginary number. I will stand for the square root of negative 1. In other words, I times I would be negative 1. Second question, the square root of negative 144. And again, there is no real number times itself that equals negative 144. What we can do to solve this one is just take the number 144, the square root of 144 would be 12, and since it's negative 144, the answer will be 12i. So 12i times 12i would be negative 144. And last question for the section, the square root of negative 100, a to the fourth, b squared, and c. So the square root of negative 100, a to the fourth, b squared, and c. Simplifying this, again, negative 100 will be an imaginary number. The square root of 100 would be 10. And since it's a negative, we'll have 10i. Square root of a to the fourth. A to the fourth, if you want to, you can write out 4 a's. And similar to the factor tree, you can circle pairs since we're taking the square root. We have 2 pairs of a's, which means we'll have a squared. B squared, the square root of b squared. Likewise, you could write down 2 b's. There's 1 pair of b's, so the square root of b squared would be b. We have a single c, so there's no pairs for the c's, so the c will stay inside the square root. Rewriting our answer, we'll have the number first, 10. The variables a squared and b we'll put second. The letter I we'll put after the variables, and the square root c we'll leave inside the square root. So our final answer would be 10 a squared bi times the square root of c. Expressions with imaginary numbers. Using the following information, we'll be able to simplify questions that have imaginary numbers that also have exponents. The first one, I, is equal to the square root of negative 1. Any questions that have a single I, we can leave with I for imaginary numbers. Second one, I squared. I squared will be equal to negative 1. I squared, we're multiplying the square root of negative 1 times itself, which would equal negative 1. So any question with I squared, we can rewrite using a negative 1. I to the third power would be I times I squared, so that would be negative 1 times I, which would be negative I. Any questions that we have I to the third, we can rewrite with negative I. And the last one, I to the fourth. I to the fourth would be I squared times I squared, or negative 1 times negative 1, which would be positive 1. So any question was I to the fourth, we can rewrite using positive 1. Any questions with I to the fifth or greater, we can simplify I to the fifth to one of these smaller numbers and rewrite them. So all the questions will either have I with no exponent or one of the other numbers. First question for the section is I to the 14th power. Again, anytime you have an imaginary number to an exponent, we can simplify that. Easiest way to simplify exponents is to take the number 14 and we'll divide by 4 and find out what the remainder is. 4 will go into 14 3 times and we'll have 2 left over, so the remainder would be 2. If the remainder is 2, what that means is I to the 14th is equal to I to the second power. So if you have any number with an I as an exponent, we can divide by 4 and the remainder is the same as the original exponent. Looking back at the table, I squared is equal to negative 1. So our answer, I to the 14th, is equal to negative 1. Second question. First parentheses will have negative 2i. second parentheses, negative 6i, and times last parentheses 4 times I. I's are similar to variables. We can multiply them or combine like terms when possible. For this one, we can multiply the coefficients. Negative 2 times negative 6 would be 12. 12 times 4 would be 48. And we have I times I times I, which would be I to the third power. Simplifying, 48 would stay the same. I to the third power, looking back at the table that we just wrote, I to the third power is equal to negative I. And if we multiply 48 times negative I, that would be negative 48i. So simplifying the expression, the answer would be negative 48i. Next question for this section is 3 minus 4i minus a second parentheses 1 minus 4i. Again, i's for imaginary numbers are just like variables. You can combine like terms when possible. If we start with the 3 and combine it with the 1, 3 minus 1 would be 2. And we'll also have a negative 4i minus a negative 4i. For minusing a negative 4, it's the same thing as adding 4. Negative 4i plus 4i would be 0i. 0i we can leave off, so the answer would just be 2. Next question for this section. First parentheses, we have 3 plus 4i times a second parentheses 3 minus 4i. Multiplying imaginary numbers or multiplying i's, we can multiply them just like a normal variable. Two parentheses we can multiply or use FOIL. 3 times 3 would be 9, and the outside terms, 3 times a negative 4i would be negative 12i. Multiplying the inside terms, positive 4i times 3 would be positive 12i. And multiplying the last terms, 4i times a negative 4i, 4 times a negative 4 would be negative 16, and I times I would be I squared. Simplifying, the 9 would stay the same. Negative 12i plus 12i would equal 0 or cancel. And we'll have minus 16 instead of I squared. Looking back at the table, I squared is equal to negative 1. So we'll have 19. Negative 16 times negative 1 would be positive 16. And 9 plus 16 would be 25. So multiplying these two parentheses, the product is equal to 25. And last problem for the section is 3 plus 4i divided by 3 minus 4i. To simplify this, one rule with imaginary numbers, similar to exponents or radicals. If we have 3 minus 4i in the denominator, one rule is we cannot have imaginary numbers in the denominator. They're okay in the numerator, but if you have imaginary numbers in the denominator, we have to cancel that out. To cancel out the I in the denominator, if we have 3 minus 4i, we can multiply by the opposite or conjugate of that, which would be 3 plus 4i. If we multiply the denominator by 3 plus 4i, we'll multiply the numerator by the same 3 plus 4i. Multiplying the numerators, we can multiply using FOIL. 3 times 3 would be 9. 3 times 4i would be 12i. 4i times 3 would be 12i. And 4i times 4i would be 16i. Multiplying the denominators, 3 minus 4i and 3 plus 4i. That's the same as the previous question we just did, which was equal to 25. So for the denominator, 3 minus 4i times 3 plus 4i, same answer we had before, which is 25. Simplifying the fraction, 9 would stay the same. 12i plus 12i would be 24i. And the 16i was actually I times I, that would be I squared. And we'll have 16 I squared, looking back at the table, which is negative 1 over 25. Combine like terms again. We'll have 16 times negative 1, which will be negative 16. 9 minus 16 would be negative 7, plus 24i divided by 25. So our answer to the question, negative 7 plus 24i divided by 25. Title of the first section today is Solving Using the Square Root Property. In this section, we'll solve equations using a square root property. First equation is x squared plus 4x plus 4 equals 25. To solve this question, we can first take the polynomial on the left side, x squared plus 4x plus 4. This is a factorable polynomial. We can factor using the diamond or x method, where we have to multiply to get 4, and we also have to add to get 4. Two numbers that multiply to get 4 and add to get 4 would be 2 and 2. Rewriting the question, using the factors of 2, we'll have x plus 2 and x plus 2 equals 25. Simplifying this, if we have the same parentheses, x plus 2 times x plus 2, we can rewrite that as x plus 2 squared equals 25. From here, we can use the square root property, which means we can take the square root on both sides of the equation, and the equation will still be equal. Taking the square root of an exponent squared would cancel, so we'll be left with x plus 2 equals the square root of 25 would be 5. Also, when you take a square root in an equation, x plus 2, instead of 5, it could be negative 5, because negative 5 times negative 5 would still be 25. Solving from here, we can subtract 2 on both sides. So x is equal to 3 for our first answer. And our second answer, subtracting 2, we'll have x equals negative 7. So our two answers to the equation, x equals 3 and x equals negative 7. Second question, and last question for the section. X squared plus 7x plus 49 over 4 equals 4. Solving the left-hand side, again, this is a factorable polynomial we can factor. If you want to, you can use the diamond method. The top number that we're multiplying to is 49 over 4, and the number I have to add to is 7. Thinking about fractions that multiply to get 49 over 4 and also add to get 7. The two fractions would be 7 over 2 and 7 over 2. 7 over 2 times 7 over 2 would be 49 over 4. And if you add 7 over 2 plus 7 over 2, that would be 14 over 2, or 14 divided by 2 would be 7. Rewriting the question, we'll have x plus 7 over 2. And our second answer is the same, x plus 7 over 2 equals 4. Again, if we have these same parentheses twice, we can write that as a single parentheses, x plus 7 over 2 squared equals 4. The square root property again, we can take the square root of both sides of an equation. If you take a square root of an exponent squared, those will cancel, and you'll be left with x plus 7 over 2 equals the square root of 4, which would be 2. Keep in mind when you take a square root on an equation, we'll have a second answer, x plus 7 over 2 equals the other square root of 4 would be negative 2, since negative 2 times negative 2 will be positive 4. Solving these equations, we can subtract 7 over 2 on both sides. If we change 2 into a fraction for common denominators, 2 over 1, we can multiply by 2. So 2 is the same as 4 over 2. And we'll have our first answer, 4 over 2 minus 7 over 2 would be negative 3 over 2, or negative 3 halves. The second equation, we can subtract 7 over 2 on both sides. This equation we have negative 2, so that would be negative 4 over 2. Negative 4 over 2 minus 7 over 2, our second answer would be negative 11 over 2, or negative 11 halves. And those would be the answers to the equation. Title of the last section today is Solving by Completing the Square. In this section, we'll solve equations by completing the square, which is a factoring technique. The definition for completing the square: the value of c, which will be the last number of a trinomial. The value of c will want to be b divided by 2 squared. And we want the value a to be equal to 1. So c again, which is the last number in the trinomial, that will be equal to b, which is the coefficient in front of x, divided by 2 squared. And we also want a, which is the coefficient in front of x squared, to equal 1. First equation we'll solve is x squared plus 16x equals 36. To first complete the square on here, we'll rewrite the equation x squared plus 16x, and we'll add to that a number, leave a blank spot, equals 36 plus another blank spot, which would be the exact same number on both sides. To find the number to add on both sides, we'll take the value of b, which again in this case the coefficient in front of x is 16. We'll divide that by 2, and we'll also square it. 16 divided by 2 would be 8, and 8 squared would be 64. So 64, the value of c, is the number that will add to both sides of the equation. So the trinomial we have x squared plus 16x plus 64. This is a factorable trinomial. If you want to, you can draw the x or the diamond, multiplying to get 64 and adding to get 16. the two numbers that multiply to get 64 and add to get 16 would be 8 times 8. So factoring this trinomial, we'll have x plus 8 and x plus 8 equals 36 plus 64 would be 100. Solving from here, we have the same parentheses twice, x plus 8. So we can rewrite that as x plus 8 squared equals 100. Using the square root property, we can take the square root on both sides. The square root and the square would cancel. So we'll be left with x plus 8 equals the square root of 100, which would be 10. And our second equation, the second square root of 100, would be negative 10. Solving from here, we can subtract 8 on both sides. So our first answer will be x equals 2. And the second equation, subtracting 8 on both sides, x would equal negative 18. So the two values to the original equation, x equals 2 and x equals negative 18. Second question and second equation for this section. We'll have x squared minus 8x equals negative 15. Solving this equation by completing the square, we can rewrite the equation x squared minus 8x plus a blank spot, which will add a new number to factor, equals negative 15 plus again another number, which will be the same number we'll add on both sides. To find a number we'll add, you take the value of b, which is negative 8, divide by 2, and square the number. Negative 8 divided by 2 would be negative 4, and negative 4 squared would be 16. So we'll add 16 on both sides of the equation. Factoring, x squared minus 8x plus 16. 16 again will multiply 2, and negative 8 will add. Two numbers that multiply to get 16 and add to get negative 8. Those two numbers would be negative 4 and negative 4. When you complete the square, the original question after you divide by 2 will always be the numbers for the solution. Rewriting the polynomial, we'll have x minus 4 and x minus 4 equals negative 15 plus 16 would be 1. Simplifying x minus 4 twice, we can rewrite as x minus 4 squared equals 1. From here we can take the square root on both sides. So we'll be left with x minus 4 equals the square root of 1, which would be 1, and also x minus 4 equals the square root of 1, which is also negative 1. Solving each of these, we can add 4 on both sides. So the first answer, x equals 5. And the second equation, adding 4 on both sides, we'll have x equals 3. So two answers, x equals 5 and x equals 3. Last equation and last problem for the section. We'll have 9x squared minus 6x minus 4 equals 0. Solving this question, looking at the values, we have a is equal to 9, the number in front of x squared. Keep in mind we want a to be equal to 1 when we complete the square. To change this to 1, what we can do is divide the entire equation by 9. Dividing by 9, the 9's will cancel, so we'll be left with x squared. Negative 6 divided by 9. If we reduce fractions, that would be negative 2/3 x. And negative 4 divided by 9 would be negative 4 over 9. 0 divided by 9 would still be 0. So anytime we have a coefficient other than 1, you can divide by that same coefficient. So our coefficient now would be 1. to complete the square on this equation, we want to have the a and b isolated and